Welcome, everyone. Thank you so much for being here. We're excited to welcome you to the SEP webinar series. This is the first in this series. This is an introduction to developing and using models. And speaking of introductions, I'm excited to introduce myself and my colleague Emily here. Hello, howdy, everybody. My name is Brendan Finch. My pronouns are he, him. You can tweet at me at BirdbrainFinch. I taught middle and high school in Los Angeles for 7 years. And I left the classroom 10 years ago to build rocketlit.com. It's kind of like a love letter, differentiated reading site for my students. And now for the last 5 or 6 years, we've been working on Inner Orbit, which is all focused around NGSS assessments. I wrote a lot of the assessments on the site. And right now, most of my work is researching new ways to better support admin, students, and teachers with NGSS assessments. And so some of the people in this meeting I may be meeting with at some point in the future to chat with, and I can't wait to do that. And I also just want to state for the record that burritos are better than tacos, and I will die on that hill. And I'm now really excited to introduce Emily.
Thank you, Brendan. My name is Emily Miller. My pronouns are she, her. I was a high school chemistry teacher for 10 years until I came over here at Inner Orbit. When I taught chemistry, I taught all the different levels, so alternative learning program all the way up to honors. So I got to see a vast range of abilities and different ways to approach science and education. When I was in my department, self-proclaimed NGSS pioneer and advocate, making sure that we're really kind of getting students to do the science, kind of what we were talking about with the practices. I was a PLC lead where we did a lot of data-driven dialogue, really getting into numbers. I want to throw out my next bullet point there for me, Brendan. I'm forgetting there it is. And my current title. I am Inner Orbit's District Engagement Manager. I serve as the central time zone all the way over to the entire west side of the country. So Wendy, that includes you over in Hawaii as well. And I don't know, burritos and tacos is a pretty dicey subject, but I hope I'm not opening up too big of a can of worms with this one, but I have strong opinions on the order of all the Star Wars movies. So if you want to talk about it, let me know. But in my strong opinion, this is from best to worst.
All right, thank you, Emily. And we don't want to start any fights here. This is about learning and growing together. And on that note, I'm really excited that y'all are here. Let's dive into our very, very first introduction, which is what is Inner Orbit? If you're not familiar with what Inner Orbit is, we want to explain it to you so that you know what you're getting into and why we feel that we can talk about these things. So first off, Inner Orbit provides phenomena. So we're on a website with this database of, at this point, over 1,000 phenomena where students can take what they're learning and then apply that learning to something novel. And that's what they have to do for all of your state tests. And that's what we want to give them practice for. And the way that we help them practice for that is by providing really deeply, highly scaffolded and targeted questions. We'll go into some of those later on in this session to allow students to access that really rigorous sense making at the end. And to make sure that you as teachers or as science coordinators are able to access all of that, every question is tagged with really discrete pieces of data. And so as you're building your assessments and you're giving those to students, you get really discrete pieces of data so that you can know that students are struggling with this aspect of the 6-8 grade level band of developing models, or they're being really successful with this aspect of the 3-5 grade level band of developing using models. These practices are complex, and we want to give you really precise data so that you can be effective and efficient with your instruction. We also find that understanding the state is a really important part of knowing how to be successful. And so we offer a lot of professional learning. There are people in the meeting right now who have been to our professional learning sessions. You're kind of in one right now, so welcome. Hi. And we would love to give you these sessions either virtually or at your school sites. So if you're interested in those professional learning sessions, or you want to meet up and learn more about Inner Orbit, you can find a time on our calendar. I'm going to drop a link to our calendar right down there, so you can click on that and pop over in, find a time to meet with Emily or Julia, and we would, or Aaron or Joy or Jasmine. We're really, really excited to support y'all. And thank you so much for taking the time to be here and grow your practice. We are gathered here to introduce developing using models. So this is the first webinar in a 2-part webinar series on the SEP developing using models. Our goal for today is to introduce and explore the SEP to prepare for classroom implementation and aligned assessments. Tomorrow's session will be focused around taking that understanding and figuring out how we can scaffold students up to the really complex practices of the practices. Hey, look at that. We're going to be here for about 30 minutes and we're going to try. We're going to try, everybody. We're really going to try. Tomorrow, it will be an hour-long session. Today, it is a 30-minute session. We will be recording this before you ask. We'll be sending out the recordings for both sessions to everyone who registered after tomorrow's webinar, probably realistically on Thursday. Great. Our agenda for today involves what is sense making. We're going to talk about sense making and the practices. There are two criteria we'll review in that context. We'll go over some sample questions. Excited about that. Emily's going to walk us through some of those. And then we've got some sample assessment items, and this is going to be the audience quiz. So you're going to take the things that you learned here, and you're gonna see how you do with these different criteria. And here we've got blue steel. Anyway, so let's dive into sense making. So before we talk about practices, we always want to talk about sense making. The NGSS is based around this idea of sense making. And kind of one of our theses at InterOrbit is how do we make sense of sense making? So we want to offer opportunities for students to do this thing. So sense making is one of the ways to think about this is taking these really disparate ideas, skills and abilities and ways of looking at the world and helping to sort of connect those things. Previously, science education was all focused on memorizing these things. And now what we want students to do is to take those ideas and take those scientific skills, those practices, and then the cross-cutting concepts, kind of the ways of looking at problems. And we want them to center around a phenomena or problem. So to apply those things in the real world. And that is the basis. Like this is ground zero for the NGSS and all the practices is this idea of sense making. And not only do we want them to connect those ideas to the phenomena, but we want them to use that phenomena to connect their ideas and their skills together. So the idea is that we take all of the ideas, the skills, the ways of thinking about the world, and we use sense making as a binding agent. We use those phenomena as ways to cement the connections between our SEPs, our DCIs, and our cross-cutting concepts, our practices, with the things we know and the ways that we view science. And that is what the three-dimensional standards are looking to drive towards. And all of this content here is all pulled from Achieve's task annotation project for science. All we're doing is summarizing that content here to provide a really clarified and specific way of thinking about this. But before we talk about the practices, we have to talk about sense making. And sense making is that process of making those connections between your skills and your ideas, and then ideally being able to apply those in novel situations. And so this is what sense making is all about. But how does that then parlay into these practices? So in other Achieve articles, they talk about 3D performance and SEPs using these two criteria. So in order for us to say that students are engaging in the practices, they need to have these two criteria. So first, they need to have the mechanics and the skills. So are you using models, genuinely using a model? Do you need to do that? Well, then that's great. That's a part of the SEP. And then then we can say, do students have a driving purpose that allows them to engage fully in making sense with that model? And if those two are true, these are two of the different criteria that Achieve uses to define the practices. So if students are using the mechanics and skills of modeling and they have a driving purpose towards sense making, then they can engage with practices. Those mechanics and skills, they're procedural features and like knowledge pieces. What this can be is, it's a necessary component. You can't ask students to use a model, to analyze a model, to cite evidence from a model unless they understand what a model is. And so it's really, really important that students understand those things. And the purpose of modeling, I had students, I like build a styrofoam model of a cell or whatever it was. And all that does is it makes what you know visible. And it helps students to represent their ideas. So I understand the mitochondria is this. I understand the cytoplasm is like all of this other space here. So that enables us to show what we know and represent our ideas. It's important to note that building of that styrofoam model or the clay, though beautiful and very impressive, It doesn't involve figuring out something new. And that's important because the whole idea with sense making is that we use a phenomena, something in the real world, for students to apply and to bind their ideas together. So just the mechanical aspects of modeling does not allow us to do this, which means that just because students are making that cellular model, like that's super cool, and it shows like I know these things and I can represent my knowledge, it's not evidence of sense making for the SEPs. And so, what ends up happening is that we give students, a bunch of, hey, like draw me a model of what we talked about in class, and they get to the point where they're supposed to do this on the state test, and they're like, watch me juggle, and it just doesn't click the way we want it to. And so the second part of engaging in practices is that not only do students utilize these mechanics and skills, but they do that with a driving purpose, and that is why a student is demonstrating this practice. And so in order for students to really deeply be engaging with a practice, what they need to be doing is making their thinking visible, not just their knowledge, but their thinking. And this is really, really helpful when students can make connections between previously learned ideas, and then they use those things to figure out a new phenomena or problem. And that's why the NGSS focuses around phenomena. We want students to take their knowledge and then make their thinking visible. And that's why they're called practices, not skills, is we're practicing science. We're integrating these two different aspects. We're integrating the mechanics of modeling and then that purpose of modeling, which is that driving purpose to figure things out. So there's some criteria that we've pulled together from many sources, namely from Achieve, in two different ways that we can look at this. And Emily's going to walk us through some examples of what this looks like. Is we can say, are students using one of these mechanics or skills? Are they referencing or reading a model? Are they citing evidence? Are they recreating a familiar model? That's important. And if they've done those things, if they're doing those things, then we can say, do they have a driving purpose to that? Do students use that model to explain novel phenomena? Are they making predictions based on the model? Or are they revising the model in light of new evidence? And that is making their thinking visible, not just their knowledge visible, but their thinking visible. And this right here, those two halves of that delicious little scientific pie up there, that's what make up the practices. And that's what we want students to be engaging with. But we need to scaffold them up to that. So in the rest of this session, we're going to look at some sample questions and figure out if they match these two different criteria. And then in the next session tomorrow, we're going to look at ways that we can scaffold students up to these rigorous performances. So I'm going to pass it over to Emily. She's going to walk us through a couple sample questions. She's going to kind of do a think aloud to model the practice of modeling and looking at these different criteria. And then we're going to go into some audience participation time. Emily, to you.
Thank you, Brendan. Yeah, modeling, that's a brain teaser to kind of parse apart there. So I've got two questions here that I'm going to model my modeling thinking to kind of see if we are actually properly assessing the SEP. So like Brendan mentioned, in order to properly assess the SEP, we need to have those mechanics and skills, but linked with that purpose. So I've got a sample question here related to the performance expectation MSPS 1.4, which is about kinetic energy. So our question is, which of the beakers in the model would have the greatest amount of kinetic energy? Now, we have a model. Yes, okay. But when we're looking at the mechanics and skills level there, do students actually need the model to answer this question? Like Brendan was mentioning, we're looking at that knowledge versus thinking. And in this case, students might just have the knowledge that gases have a larger amount of kinetic energy based on what you talked about before. In fact, I could even cover up this picture and potentially still answer this question. So really, are students using one of these mechanics or skills? No. I would say that they're not even utilizing the skills here that we need to teach in terms of modeling. So this one kind of like right off the bat is kind of like like you can't just slap a picture in a model and call it developing and using models. And I'm going to show you some more here where they actually are using those mechanics and skills as well. This may be a surprise, but if students aren't using a mechanic or skill, is there a driving purpose then? Nah, probably not. This probably wouldn't even be considered novel phenomena, at least in my experience of teaching kinetic energy and particle motion. I've got a bajillion slides that kind of show things like this in simulations. So they probably already have that mental picture in their head. So they're not even challenging themselves to kind of get to that sense making and try to figure out something new. So this would not be properly addressing that. But I've got another question here for you connected to the same performance expectation, so the MSPS 1-4. So this question, Jose decides to draw a model to show what occurs at the particle level in the two different beakers. Jose's teacher mentions he has some inaccuracies. Which of the following changes could Jose choose to make his model more accurate? So when we're looking at that criteria here, are students using the mechanics and skills? In this case, absolutely, yes. We have to look at Jose's model in order to answer the question on how to make Jose's model more accurate. So we need to be interacting with this. We need to decipher this. We need to read this, look at the key. So right away, we're using our skills of how to interpret and use models. But now the important part is, do we have that driving purpose? Now, novel phenomena depends on if you did this activity or not, but we are revising a model in light of new evidence. So based on what Jose has, students have to show their thinking and say, how could Jose have done something different? What do I know about particle motion that is not currently being represented? So do students have one of these driving purposes? Yes. So we've got our mechanics and skills. We've got our driving purpose. Our delicious science pie is fully made and realized. And so we are properly addressing that SEP in this case. So next, what I have for you, because clearly after those like 5 minutes, y'all are experts, right? I'm going to throw some questions at you, just like the ones I just showed. And I want you to ask yourself the two main questions of, are students using their mechanics and skills? And do students have a driving purpose? So, and again, once those two things are there, we know that that SEP is being properly assessed. So performance expectation here, we've got some elementary, 5 PS3-1. Our question is, the owl gets the energy it needs to live and grow from, we have some options. So here's what I would love all of you to do, because participation always makes this more fun. In the chat, could you please answer the two questions? Are students using a mechanic or skill? And do students have a driving purpose? You could literally type like no, no, or yes, no, or no, yes, or some combination of that. But challenge yourself to actually participate, get your brain cooking. What do you think? Ooh, extra credit. Yeah, I mean, the extra credit bonus points in life, those will take you far. So I feel like I need like the Jeopardy music playing. I'm almost tempted. Like,
We tried that before, and people were like, please never do that again.
you know what? Fair enough. I will not participate. Oh, also, if you are participating in the chat at the top, you can send it to everyone rather than just sending it to the hosts and to the panelists. And that way everybody can kind of see your thinking. So more fun to have more of a discussion with the whole group than just with me and Brendan. So I do appreciate seeing what you're thinking here as well. Okay. All right. Love this. Beautiful. They're all pouring in. Okay. I'm going to go ahead and start talking about this a little bit. So are students using one of the mechanics or skills? So we're asking, does the owl get energy? The owl gets the energy it needs to live and grow from what? Now, here's the thing. I might remember that an owl is a carnivore, that owls eat birds and plants. And if I look over at these models, there's a bunch of different things where owls are getting stuff from. So if I just remember that an owl needs to eat actual carnivorous things, I actually don't need to look at this at all. So are students using one of these mechanics or skills? I'm going to go with a no on this one. They don't actually need the model. So again, kind of like give yourself that test. Could you cover up that box and could the student still answer it? Not like, are they guaranteed to answer it? Maybe a kid doesn't remember what owls eat, but like, could they, in theory, if they remembered that one lesson from that one day, could they do that? So again, we've got to know on the mechanics and skills here. So generally speaking, do students have one of these driving purposes? No. Whether or not this is novel phenomena, we're not making predictions, we're not revising the model. So one, we're not actively using the model, and two, students don't have a driving purpose behind the model as well. So we're going to go with a no and a no on that one. Thank you so much for participating. I tried to make this one a little tricky on purpose. Let's go ahead and look at another example. So this one uses the same exact performance expectation. So I want to make note of that. So 5 PS3-1. This question is, a student drew this model for a hawk, which is also a meat eater. What could the student add to help the model? So remember, our two criteria are students using mechanics and skills, and do students have a driving purpose? So again, I loved seeing everybody's answers last time. Again, you can just kind of say like yes, yes, no, no, yes, no, no, yes. I think those are all the options. Yep, that sounds about right. You can throw an IDK in there if you want to. I'd always tell my students, just give me something. Even if you don't know, tell me you don't know. Right. Seeing lots of yeses popping in. Okay, there we go. You can see the answers there. All right. So a lot of yeses pouring in. So are students using one of these mechanics or skills? I'm going to give a yes to this one. In order to figure out what the student could add to help the model, I kind of got to look at the model, right? So I have to see what's currently going on. I have to use my skills. Where are the arrows pointing? How is this all connecting? What did my teacher say about food webs? So I need to use these skills here in order to answer the question. So then, do we have one of these driving purposes? Yes, we need to figure out a way to revise this model. So we need to somehow get the sun in there. Again, that's a key part of that performance expectation. So how does the sun play into all of this, making sure that we hit all these points? But we're going to give this one a yes, yes. We have to interact with the model, and we have a purpose behind using that model. Everybody's doing awesome, fabulous. I got a couple more for you here. Let's go ahead. Maybe we'll speed this up a little bit just because we're getting to be pros now. Middle school one, your friends are discussing how the mountain could help to cause rain. Who has the most accurate answer by using evidence from figure one? Go ahead and in the chat, give me yes, yes, no, no, yes, no, no, yes to our two different criteria here. All right, some answers coming in here. Beautiful. Okay, so are students using one of these mechanics or skills? I'm going to give a yes to this one, mainly because the question specifically asks who has the most accurate answer by using evidence from figure one. So we need to cite evidence given to us in the model in order to answer the question. So when we're looking at Marcus and Caden and Venus, they have to actually be pulling evidence from the figure. So we need to be referring to it. And then, do students have one of these driving purposes? Yes. One, I would hope this would maybe be novel phenomena if you're putting this on an assessment question. But two, they have to make a prediction as far as could mountains help cause rain? So this idea of making a prediction, okay, the arrows are getting blue. What would that cause? Like, why is the rain now forming? So they have to make a prediction of the event that will take place by citing evidence from that model. All right, Brendan, you think we've got time for one more?
I think so. And y'all are doing great. Thank you so much for
Mhm.
your participation. And I have to say, I think we're getting further. We're moving the needle here because the first question was rocky and that was awesome. So good job.
Growth. I love it. Okay, I wanted to do one more because I didn't want to leave my high school people out. So we've got a high school performance expectation here. So good old cellular respiration. Use the letters from the following key to correctly complete the diagram above. So again, we've got our two criteria here. For students using mechanics and skills, driving purpose. Go ahead and throw it in the chat one more time. This will be our last one. Go for the gold here. Okay. All right. I'm loving seeing these answers because I really wanted to talk about this one. Beautiful. So are students using one of these mechanics or skills? If we really want to get to the SEP, I don't know if this is the best way to use a model, in my personal opinion. Because really, let's talk about what this model is asking us to do. It's looking at us to look at that chemical reaction of cellular respiration. Do I need this model to know that cellular respiration gives off water and carbon dioxide and you need oxygen and glucose? Yes, glucose. Okay, yeah. In order to do this, yeah. If you have that knowledge, you don't need this model in order to answer that question. So in this case, you could have phrased this question in a lot of different ways. You could have just had like a chemical equation. You could have had a drag and drop, a matching, but they just chose to use pictures instead. So since we're choosing to use pictures instead, that's not necessarily getting into those modeling skills. I put a yes because they do need to kind of like understand the arrows and the blanks. But I would say if we want to get into that modeling, I don't know how much we're using here. So then in that case, do students have one of these driving purposes? I'm gonna go with a no. They're not necessarily revising the model. We're not asking them to fix it. We're just asking them to put in some blanks. So we're basically giving them a list of options and we're just saying like, put this here. All right. Thank you so much again for that participation. This makes it so much more enjoyable. And I'm going to go ahead and hand it off to Brendan to wrap us up here.
So thank you so much for being here with us for this webinar. It's absolutely fantastic to see everyone here. We do have a webinar tomorrow on the same topic, but this was intended to be an introduction to the SEP and really to focus in on those two different criteria of practices. And tomorrow's webinar is going to be an extension of this. So we're going to start here where we ended, and then we're going to go much further. So we're going to talk about different ways to use different questioning strategies to expand upon these ideas. And then we have some scaffolding sort of research and templates that we've been building, and we are excited to share those with you too. So we have some new stuff we're going to talk about tomorrow as well. Thank you all so much for joining this webinar. We are very, very grateful for it. I hope you have a beautiful rest of your day.